Hello, welcome back. We are doing 11.1, number 1. Now, in this amazing problem, you're dealing with a situation. You are, well, hold on, that's not you. That's you, because you are hanging onto a spring. Now, the spring has got a spring constant of 500 newtons per meter. So the question is, Earthlings, how much is that spring going to stretch because you're hanging on it? So let's do the math. Now in my case, it is my mass times gravity. Obviously, if I'm in space, it ain't going to stretch, is equal to the spring constant times how much it stretches. Now, since this is a vertical spring, I'm not going to put down x, I'm going to put down y, because it is stretching downward, right? Now, let's get started. So, my mass is 108.9 kg. The gravity, Earthlings, is 9.8. I'm going to go take care of this because it's driving me nuts. And that is equal to negative 500 Newton meters. And our distance is what we're going to try to figure out. What is y going to equal? So, multiply these together. Mass times gravity is your weight, in my case 1,067 newtons, is equal to negative 500 newtons times meters times y. Divide both sides by negative 500 Newton meters. And then over here, divide by 500 Newton meters. Sorry, that's Newton meters. Okay, newtons cancel, units cancel, that cancels. 1,067 divided by 500, I get 2.134444, blah, blah, blah. And the only unit that's left is meters, is equal to, well, negative. Sorry, don't forget the negative. Negative is equal to y. Now, why is it negative? Well, when you think about it, this is supposed to be my gravity is pulling down. That's the force of gravity. The spring force, the elastic force, is pushing up, right? Now, our direction has been up, but I'm stretching down, aren't I? So we have negative, we can say it's negative, well, let's round it, negative 2.1, 2 sig figs, meters up, or I can say positive 2.1 meters down. Either way is fine. Both are correct. It just is depending on how you look at it. A lot of people just leave the negative out because the only reason you have negative there because if the force goes you stretch one way, the force goes the other. Most people just remember that, but I just left it in there just to leave it in there. But anyway, there you are. Now, quick question. If you are less massive than I am, it stands to reason you're going to be less heavy than I am. So you're probably going to expect the spring to stretch a little less just because you're not as heavy. So just think about that, okay? So if you get a number, if you're smaller than me and you get a number that's bigger than mine, you've probably done something wrong.